Hi, good morning grade 12 student. This is our 7th lesson and this small part from lesson number 6, finding the pKa from titration curve. We finish in lesson number 6, titration curve. So how to get pKa value from titration curve? You need to follow these 4 points. Suppose during an acid-base titration 25 cm³ of alkali is required to neutralize a weak acid. Therefore, at half neutralization, mean half volume of alkali has been added, that is 12.5 cm³. So, you can see a point number 4, conclusion: pKa is the pH of solution at half neutralization. If your complete neutralization, you need volume 25 cm³. What is the half of 25 is 12.5 cm³. Look here in this equation, Ha for acids. When you add alkali into acids, then you will get water and this base. Half of the acid has been neutralized and half of the salt has been formed, because whenever acid and base combine together, they form salt and water. So this example is a salt. So when half acids neutralize half of salt, therefore we can write Ha for acids is equal to A negative for any kind of salt. So these two are equal at 12.5 cm³. According to the formula, log of acid over salt is equal to 1, that is pKa is equal to pH. Now use this equation for calculation how to get pH value from titration, pKa value from titration curve. If pH is given to you, concentration of acid is given to you and concentration of salt is given to you, then substitute the value of acid here, concentration of acid, here concentration of salt, pH you can find out from titration curve, you will get the value of pKa. Actually pKa is the pH of half neutralization, at half neutralization. This from the previous lesson. Now today our lessons about buffer solution. These are your objective. Define the term buffer. Then you need to explain how buffer solution can control the pH by adding acidic and basic buffer solution. Then calculation about the buffer solution by using the equation Anderson-Hazel-Blake equations. Hazel-Blake equations. Okay. Now, what is buffer solution first? A buffer solution is a solution whose pH does not change significantly when small amount of acid or base is added to it. Actually, buffer solution is used to resist the pH, sudden change in pH, and used to stop sudden change in pH. Now, buffer solution should therefore contain, what is buffer solution? A large amount of acids to react with base added and large amount of base to react with acid added. It means you have two ways. Now you can see the next detail. Since the added acid and base can be removed, the pH does not change. If you are going to add small amount of acid or small amount of base, the pH will not change because we are going to use the buffer solution. These conditions can be achieved if the solution contains a mixture of weak acid and its conjugate base or weak base with its conjugate acids. So it means you have two types of buffer solution, acidic buffer and basic buffer. Now what is acidic buffer? Acidic buffer solution is acidic and can be made by mixing weak acid and its conjugate base together. Weak acid, this one weak acid, CH3COH, ethanoic acid is a weak acid, and ethanoate ions as an example. This ethanoate ion is a conjugate base. So when you add weak acid and its conjugate base, this type of buffer is called acidic buffer. Now, second type of, and first let me to finish this one. What will happen when in this acidic buffer we are going to add small amount of acid or small amount of base? What is the change actually? Then we will start second type of buffer. So when acid is added, this very important objective, that what will happen, what is the function of buffer. So you need to memorize, please. The hydrogen ions from the acid is added will react with the large reservoirs of ethanoate ion. When you add hydrogen ion, it will react with ethanoate ion, mean conjugate base, and the formation of ethanoic acid take place. So the extra hydrogen ions are removed and the pH drops very little. So what happened by adding acid in acidic buffer? So this is your answer. The pH drops very little. Now what will happen when base is added to acidic buffer? When you will add base, OH in ethanoic acids, you will get ethanoate ion in water. So when you add OH negative, these hydroxide ions are removed and the pH increase very little. Look at here, when you add acids, pH drops, decrease very little. When you add base, pH increase very little. There is no large difference. So very small change in pH in acidic buffer when you are going to add acid and then you are going to add base. So this concept you need to memorize, that when the pH slightly increase and when the pH slightly decrease. Now second type of buffer solution is alkaline buffer. In alkaline buffer, by mixing of weak base and its conjugate acids together. Now weak base, before weak acid. Now the second type of alkaline buffer, mean you can say basic buffer, by adding weak base and its conjugate acids. Weak base here, ammonia. When you add in water, you will get OH negative here and ammonium ion positive. Now, here in point number 3, they mention the presence of ammonium ion cause the equilibrium position to shift to the left. This presence of ammonium ion, this shift the position to the left side. Then what happened with the solution? Large reservoir of ammonium molecules and large reservoir of ammonium ions, enough hydroxide ions to make the solution of alkaline. This is information how to get alkaline solution. Now what will happen when you add acid and base? Similar like above, when you add acid in weak base, then pH drops very little, and when you add alkali into ammonium ion, then pH increase very little. So this is last line. This is your concept, that what will happen by adding base to a buffer alkaline solution, what will happen by adding acid to alkaline solution. So this is your concept by adding acid and base. Now calculation. So this is the last part, how to calculate buffer solution. So one example is given here, calculate the pH of buffer solution. This is the question, calculate the pH of buffer solution containing 0.600 moles per dm cube propanoic acid and 0.800 mole per dm cube sodium propanoate, and Ka value of propanoic acid is given to you. So you need to follow some steps. Step 1, write the equilibrium expression, product over reactant. H positive, then propanoic acids here, propanoate ion, and then our reactant propanoic acids. Then rearrange the equilibrium expression to make hydrogen ion, because we are going to find out the concentration of hydrogen ion, Ka given to you. Then you have to take, because both are cross multiply, so just replace their position. Here write Ka, then here H. So hydrogen ion concentration equal to Ka times propanoic acid over propanoate ion. Just rearrange these equations. Note that this expression, the ratio determining hydrogen ion concentration, and hence pH is the ratio of concentration of the acid to the salt conjugate base, as we did before, and even I wrote here the equations. These two formula you need for calculation. First, if Ka given, you need to find out the hydrogen ion concentration, then you write acid over salt. And second rule, directly you can use this one. You are going to find out the pH of buffer solution. You need pKa. If Ka given, take negative log of Ka, you will get the value of pKa. plus log 10 of salt, concentration of salt over concentration of acid. So these two rules, any rules you can use. Look here in this exercise in step 3, first we rearrange because we are going to find out concentration of hydrogen ion. So hydrogen ion is equal to Ka is given to you times concentration of acid is given, concentration of salt given, just substitute the value, you will get the hydrogen ion. And in step 4 calculate pH. So you know from previous lesson pH is equal to negative log 10 of hydrogen ion. Hydrogen ion take concentration from here, substitute the value, you will get the pH of buffer solution. This is the first way you can use the first rule. Second rule you can use here, another examples given to you, and then you can see for more example the ionic equilibrium notes and also the assignment number 3. Calculate the pH of buffer solution when 50 cm cube of 0.1 molar solutions of ethanoic acid mixed with 150 cm cube of 0.3 molar of salt. Concentration is given, Ka given to you. You need to find first the number of moles of salt and its conjugate base, then substitute in this rule. Look at here, then Ka is equal to Ka we know, hydrogen ion is equal to Ka we know, concentration of acid we know, concentration of conjugate base we know, you will get pH, take negative log and you will get pH of this. Now the final example is also given, please follow, both rules are given here, many other examples, hope you will understand. This is all about the unit 3. Next lesson inshallah I will give you revision for whole unit.